Welcome back. We're going to continue our unit by solving logarithmic equations. This is going to be a short video. We will go in much more depth in class. But again, there are two basic strategies for solving logarithmic equations: one-to-one property and the inverse property. Now, to solve a logarithmic equation, like natural log x equals 3, clearly there's no good way to do that with like bases. The natural log, and I'm going to write it in here kind of little, put it in right here. Remember, the natural has a base of e. We're just going to shove that in there. We don't normally write that little subscript for e, but it is there. So just to remind you, these things do not have the same base. Now, one way to do this is to do what they call exponentiating each side. And exponentiating is just a very fancy way of saying raise both sides of the equation to an exponent using the same base. So here, if you look, they've taken the natural log and the 3, and they've raised them into the exponent. And they've exponentiated using a base of e. Now, what that's going to do is remember the inverse property. The e and the natural log of e have the same base, and they're inverses of each other. So they're going to cancel out, which is going to leave you with x equals e cubed. Now, another way to think about that equation is to simply remember our ben beni. This is our base. This is our number. This is our exponent. If I go from beni, which is logarithmic, to ben, remember ben is b to the e, equals n. My b is e, little e. My e for the exponent is 3. And my number is my x in this case. Simply by rewriting it, I got it. So sometimes you don't have to go to that process of exponentiating. You can simply move from logarithmic to exponential form, and it'll take care of that for you. Here we have another situation that's very similar. Natural log of x equals 2. They exponentiated, cancels, and you have x equals e squared. Same thing if I changed from b and e to b, e, n. My base is little e, natural log, exponent. My exponent is 2, and my number is x. And so I've gotten the same exact answer by simply switching from logarithmic to exponential. Now this one, they're using the one-to-one property. If you notice, everything on the right and everything on the left has been reduced down to one term. And they both are logarithmic terms with the same base. If that is the case, we can do that. And we can merely set these pieces equal and solve for x using the one-to-one property. Now, if you had this, you could not use that one-to-one property because you do not have that log term on the right-hand side. Here's one that is much more complicated, but it's really not that hard. If you notice, everything has a log base 6. That's a good thing. If you notice also, the right-hand side only has one term, but the left-hand side is one log base 6 subtracting another log base 6 term. So we have to do the condensing first using the quotient property. So when something is expanded as a difference, we condense it back into a quotient because of our rules of exponents. So we will have the 3x plus 14 divided by 5. Now we can apply our one-to-one property. And we'll have just the 3x plus 14 over 5 equals 2x. And you've got a couple of different ways to solve this. Probably the easiest way is to multiply both sides of the equation by 5. And then you'll have the 3x plus 14 equals 10x. And we solve. We will see more of this type as we go through the next couple of days. But this is an excellent intro to what is coming toward you.